Good morning. Welcome to the daily part on data analysis. Okay, so let me just see whether I have put my recording on or not. Okay, I think I have put it on. Right, let me start with the recording part. Right. Okay, so data analysis, as you all know, this is one of the very important part or topic in the IBDP curriculum. So data analysis is not about numbers. It's about understanding what the numbers are telling you, which we already know. And, in today's world, analyzing data is very important. And that's where different types of jobs are coming out, known as data analysis jobs or data analytics. There are several things people are doing it now. Okay. So now let us understand from your IBDP point of view. So what do you have in this data analysis? How much do you need to learn and what you need to do? Okay. So, right. So for data analysis for paper 1, 2025 exams, it starts. So this is from the next year. It's a critical but yet an under-emphasized area in IB physics. In fact, this part of the paper was already there in your previous curriculum also, or from the very beginning. We had this in paper 3. Now paper 3 has been removed and we directly have only paper 1 and paper 2. So there is no specific textbooks making it very challenging for students. What students are doing or what teachers we are doing it is that we are so far we teach a part of this and we see to it that okay we take up the examples from the past papers and then we teach them. And as we keep on giving the past paper examples, we tell them what is the theory behind it. That is one important thing, and there is no specific textbooks available for it. And as a result of it, I thought this would be useful, so I started doing this. And then many students rely solely on past papers, which is still, I feel, is not enough. You really need to have some amount of theoretical background to work on this. And it is very important to analyze and interpret the data appropriately, without which you will not be able to solve it in papers. And the weightage in exams for both SL and HL paper is it is seen to be 15 marks in paper 1. Okay, so therefore, it's extremely important for you to understand how to analyze the data, how to interpret the data, and what is graphical data analysis, what is significant figures. In fact, this year they have removed even significant figures from the chapters also, because we start directly from the kinematics. Okay, so who am I? First thing. So about me, I am an IB physics teacher at one of the international schools in Bangalore known as Jain International Residential School, JRS. And I had been recently putting across so many videos in YouTube. So far, I have already completed around 1,000 videos on problem solving. What I have done is I started with JE and NEET level problems. Okay, the interest was to take up those problems and see to it like what are the misconceptions students actually make. Okay, so what I used to do is I had a hobby of looking at the answer sheets of the paper of the students and looking at what kind of mistakes they do, why did they do, and looking for patterns in that, and then started to interview them and ask them, okay, what was the reason why they got it incorrectly? They used to come out some reason, okay, and then I need to jot out all those things. Finally, I have come out something like misconceptions in physics. That means while you solve a problem, you will have one idea in mind. But then what happens is when you finish your problem and come back, then you realize that this idea that you had, okay, was similar to the actual idea. And as a result of it, you made a mistake. Which means it's something like you solve a problem thinking that this idea is correct, but finally it goes wrong. The reason is two ideas are very similar. So you should know when to apply one idea, when to apply an idea, and when not to apply. This has not been taught anywhere. So that is what my interest is. If you can go to my website over here and you'll be able to find okay lots of questions based on this. Okay, and I'm basically interested in experimental physics, though my backgrounds in physics are electronics and so on. And I'm also interested in looking at the patterns in problem solving and then simplifying complex concepts in physics. So if I have a very complex concepts, I see to it like how it can be made more easier. So that's what I'm looking at. So towards it, I have already developed a channel, okay, for solving the problems in IB physics, like considering 1 minute for one problem. Do not take more than 1 minute to solve one problem. And as a result of it, all the past papers, most of the past papers, I have put it across. Okay, now let me go back to what is that we are covering in this unit. The units that we are, or the concepts that we are covering here is how do you graph and what is data visualization. So what do you understand from graphs? And then we also look at hypothesis testing, meaning that it's not actually the null and the alternate hypothesis which you are going to test, which you learn in the statistics. So here the interest is about how do you lay a hypothesis? What are the important tenets of laying a hypothesis? And then after that, we are also looking at uncertainties and error bars. What do you mean by an uncertainty? How do you use error bars? Okay, how do you, what is that you understand from it? What is propagation of errors? We learn all this. And then we look at curve fitting and mathematical relationships. How do you linearize something? Okay, how do you fit a curve? And what are the mathematical relationship between an equation and a curve? So these kinds of things are being done. Purely this data analysis or the concepts covered in this data analysis video are only from the IB perspective. Okay, this is not something like an alternative to the data analysis that you require for your jobs or anything like that. But anyway, I feel this is very, very important for someone, which will definitely help him to have a lot amount of critical thinking and logical reasoning. Okay, let us move on. Now, when we talk about data analysis and graphics and visualization, okay, the first thing is that, okay, we need to look at what kind of graph to choose. If given data, the first thing that we think is that, okay, we can choose any graph. That is incorrect. We need to think about what kind of graph to be chosen. There are several types of graphs. We have line graphs, bar graphs, scatter plots, and etc. For example, shown here is nothing but a graph of mass versus weight. See, as the mass increases, the weight also increases. So first, what we will put is we plot the coordinates, and after that we put something like a straight line. Draw these coordinates with a straight line. You get a straight line graph. We call this as a line graph. Now, if you go to the next slide here as shown, so the same graph is being drawn even using a bar chart here. Now, which chart is more commendable? Which chart is more recommendable? Okay, if you ask me this question, then definitely I will say this chart is more useful for me as compared to this. So, what could be the reason? The reason is because so if you plot points like this, you get a straight line here. The moment you see a graph, what is that you will understand? You will always think, why don't I find a slope here? If I find a slope here, what do I get? I get a slope here equal to 10 Newton per kg. What does this give you? This gives you the value of g. That is the acceleration due to gravity or gravitational field. Now, I don't get the same feeling when I come back to this, right? So here, what do I get? I get something like the numbers are plotted here. It only tells you what is the weightage of these numbers, okay? Though the data is same on both the sides, what is the weightage of it? If the value of this particular variable is 0.2, the weightage is smaller. If the value is increasing, then the value is larger. The weightage is larger over here. For example, here if I have a value of 1, I get the weightage to be nearly equal to 10 over here. Right? That's what I can understand. But here I can get the notion of applying for a slope. The second important thing that we get here is that, see, when I have something like this, what else can I say? Say, for example, I have the values for 250 grams and 500 grams. If I want to get a value for 400 grams, 400 grams would stay somewhere over here. So what I can do is I can drop a line here, perpendicular line, and at the same time, I can find out what is the corresponding weight over here, which is 4 Newton, right? So therefore, I will be able to understand how the conversion goes. I'll be able to do something called as a prediction, okay, which I will not be able to do it until and unless I consider a line graph here. How do I draw a line graph? Once again, I take the midpoints of each of these bars and then draw a line based on this, and only then I will be able to predict it. Okay, so if I want for 0.4, then I'll put a line here and see this grid line intersects at this point. I will be able to find out what could be the corresponding weight here. So this is how line graphs are more utilized as compared to a bar graph or with a scatter graph. It depends upon what is your context, and hence you can decide which graph to be chosen. Okay, let us move on to the next one. There are several types of graphs available. The first type of graph is your line graph, which we have already seen. The next one is about bar chart, histogram, pie charts, scatter plot. There are a lot number of graphs which are available. If you go to MS Excel, you will see there are so many graphs which are available. Okay, and in today's world, people are not using MS Excel; they are using Tableau. Okay, and several other data analytics tools. In fact, that itself is a very huge branch. Okay, bubble chart, a web chart, something and all they are using it. Okay, so it's very, very important to know these types of graphs, when to use it, okay, how to understand these graphs. Because see, these softwares can give you any number of graphs, but you are there, you should know how to interpret them. Okay, and easier interpretation will be possible, okay, only in certain graphs. You should know how to interpret which graphs over here. Right. Let us move on to the next one. Now, of these so many graphs, the following graphs which are highlighted are very important, which really tells you, okay, something about the data that we have. We have line graphs. In many of the IB problems, we will be using line graphs. In fact, we can use it in our IAs and EEs also. In bar graphs, also we use it at many places. We can use it for categorical comparisons and so on. So let us look one by one. So line graphs we have used it at several places. Where is this been used? This in case of your thermal physics, wherein how does the temperature of a hot cup of coffee, okay, so decrease, or maybe you want to find out like what is the temperature of the environment, okay, the outside. For example, I put a metal plate outside, okay, and I want to monitor what is the temperature of the metal plate as the time proceeds over a given day. Now you see, temperature initially at 6 a.m. is smaller, 35 degrees Celsius, and then slowly you see it increases here, it increases to a much larger, and then slowly it decreases over here, right? So therefore, these kinds of graphs are helpful for us to understand the trends, or if the data is continuous, then these kinds of graphs are extremely useful for us. The next kind of graph is nothing but your pie chart graph. Now, pie chart graph, most of the time we don't use it, but yesterday I was just browsing through the net, I came across this particular problem where it was really wonderful to use at pie charts. Maybe who knows, tomorrow in your IB paper, in 2025 IB paper, a similar problem might also be asked. So you should know how to use these kinds of graphs also. So as you see here, a ball is being rolling down an incline, and as a result of it, the total energy here is due to gravitational, which is being shown by a single circle. And as the ball comes to the second path over here, you see, so 75% of this is seen to be gravitational potential energy, while 25% of it, one sector of it, is seen to be kinetic energy. And here you see 50%, third position, 50% is seen to be gravitational, 50% is due to kinetic. And the last one, there's no GPE, all of them have got converted into kinetic energy, right? So this very simply, in a very simpler manner, the transformation process between a GPE to a kinetic energy has been very clearly explained. So these kinds of graphs are very useful. So you should know how to interpret it. That's very, very important. Okay, now let us move on to the next type of graph, which is nothing but a scatter plot. In a scatter plot, as you observe, there are several dots seen over here, and this is a plot of velocity of a particle versus the kinetic energy of the particle. Now you see, you have more number of dots in this region. Now as we go here also more number of dots, but when I go further over here, the number of dots reduces. And you see, some of these dots are only above this level. Okay, many of these dots are not below here. What is this level here? This level value is seen to be around 5.93 and 6.59. That means these are having a larger kinetic energy, larger velocity, and hence you can see larger kinetic energy. Now, what does this help you? Where does this help you? It helps you in understanding the velocities of the particles present in a system, but present in a system, are the distribution of velocities, in a system. For example, I can have something like a gas. In a gas, what kind of particles, how many particles are having higher velocities, how many are having lower velocities, what distribution, what fraction of it is having, something like this. Then such questions can be asked or can be answered using the scatter graph over here. Okay, let us move on to the next one. The next type of graph is nothing but your box and whisker plot. So a box plot, we call this as a box plot. This is extremely important in every part of your IB curriculum. You use it in problems, you use it just in your IAs, you use this in your Es also. Now, as you see here, you have the miles per million gallon of miles per gallon for all vehicles. Okay, if you have 1 gallon of fuel in your vehicle, then how many miles does it actually cover? Okay, if you ask this question, you can say some of these vehicles can cover a distance of 10 miles. Some of them can cover a maximum distance of something like 42 miles. But on an average, you see, most of them cover an average of around 25 miles per gallon, right? So you have put it across something like a box and a whisker plot, and that's how you are able to see it. You can specify what is the minimum, you can specify what is the maximum, you can specify what is the median. Okay, so most of them are lying in this region, so you can find out what is the median here, and therefore you can say if you buy an first hand or a second hand vehicle, then there is a possibility that your vehicle will be able to give something like 25 miles per gallon. And if you are buying a vehicle and it gives you lesser than 25 miles, maybe there's something wrong with it, it's a old version of it, do not go for it, right? So much information is being conveyed using one type of graph here. Okay, let me move on to the next one. The most popular graphs seen in exam, I already told you, this is the kind of graph that we see. So what does this tell you? This is nothing but a plot of T versus 1 by H over here. So as you see here, just a minute, let me pull this. Right. Okay. So as you see here, okay, this is in per meter and this is in second over here. Now you have something like a whisker plot here. So this is the actual value. Let us take up one value. Let us say this value here, T is equal to 1 second over here for a per height of, let us say, what is this? This is now 4. This could be 2, 2.4, 2.8, 3.2, 3.6, and 4. Okay. Every unit along this direction is seen to be divided into 0.4 units. What did I do first? I looked at the graph. I did not read the question. First thing what I did was I looked at what does the minimum deviation correspond to. See, don't learn, okay, how do I solve a problem or what is the solution for a problem. Learn about what is the process of solving a problem. Very important, because today I may teach this particular chapter or topic for 15 minutes or 20 minutes or half an hour. But while you apply this one, you should be able to remember this forever. So therefore, it's very important for you to understand the process as how do I work. So therefore, each part over here represents a 0.4 over here, and each part over here represents, what does it represent? 0.5, 0.6, 0.7, 0.8, 0.91. So therefore, this is equal to 0.1 over here. So each part here represents 0.1 seconds. So therefore, now you see the time that you are measuring here is 1 second actually. But if someone else measures, okay, you have conducted the experiment, you have got 0.1 second, you have got 1 second for this particular per height. But tomorrow, if someone else does the same experiment, same protocol and so on, but he may get 1 second, he may get 1.1 second, he may get 0.9 second. Okay, that's what it tells you. It tells you the range or the variability of the values, okay, which is possible for you to get this one. In fact, this also tells you that maybe you have conducted three trials for this particular value observable, and as a result of it, first time you got something like 0.9, second time you got 1, and third time you got 1.1. It's not only that only 3 trials. Maybe you would have conducted something like 10 trials. Okay, first time you got 0.9, 0.93, then you have got 0.95, then you have got 0.95, 0.92, and so on. There are a lot number of variations, and all these variations are subjected to be within 0.9 to 1 second. Okay, this is also a possibility, right? So therefore, this gives you a range in which your experiments can go wrong. Not go wrong, that is, it can vary over here. The particular variable can vary. Okay, let me move on to the next one. Now it's very important for you to label the axis. For example, if I give you a graph like this, the same mass versus weight graph, you see here, so we do not know what is written here, what is written here. Any graph that you take, if they ask in the question, spot the mistakes in the graph. Okay, these kinds of questions can also come. So first thing that you need to do is look for what is the mistake here. The major mistake here is nothing but where the labeling has not been done on both the x and y axis. Label the x and y axis, put the units corresponding to it. That is very, very important. Either from doing a problem over here or conducting an IA or your EE in your research. Okay, next. Set up appropriate scaling. Okay, this is the next important point. Okay, while these are all practically important things for your IA and EE, sometimes it will also be useful in theoretical questions in your paper 1, right? So here, as you see, the mass versus weight, I have given some values over here. It's being plotted over here. See these 4 values. Now, how many values are here? 1, 2, 3, 4, 5, 6, 7, 8. 8 values are here. But if you look at the graph, I am able to see 1 here, 2, 3, 4, 5, 6 over here. What is the reason? Because you see, these 4 values are being crunched together. These 4 values are being crunched together, which are being present in this dot itself, right? Within 0.18. Okay. So therefore, these values are not been observed here. So what you should do? You should set up appropriate scale. Why the reason is because this graph is being set for a larger values. So whatever is happening over here, this pattern has been missing over here, right? So as a result of it, let us look at what else we can do. We can do something like, we can have a separate graph for smaller masses, okay, which gives you for 0.1 what is the variation, 0.11 what is the variation, you get something like this. And you can have one more separate graph for the other one, which gives you something like the other values, okay, for masses and weights over here. So this will definitely help you out, okay. So whenever you draw a graph, see to it that what is the range, in which range, okay, is the graph points being clustered around. And if you see a quite good cluster, see, so this is one cluster, this is one cluster over here, this is one cluster, and this part is the second cluster over here, second cluster. What is meant by cluster? A cluster is something but a group, right? You have a group of points here, you have a group of points over here. So what you do is, for this group of points, you can draw one graph. For this group of points, you can draw the other graph. Because in between them, there's a large difference over here. So it does not account for it also, right? So therefore, you can do something like this also, right? Next, let us look at, so far what we have learned, we have only learned about the, how do you draw a graph, what are the variable steps, right? Next is about errors and uncertainties. So here we'll look at what about the types of errors and how do you handle the uncertainties. Okay, now look at this example here. So you have something like, you have kept a coin over here. This coin is kept here, and it's seen the student measures the reading to be around 6 centimeters here. So is this correct? This is not correct. Why is it incorrect? The reason is because this is not 6 centimeters. This coin should have been kept here, as is seen over here. So it is being kept over here. Many students do this one here. Reason is because they don't see whether it is being kept at the 0 point or not, right? So therefore, these kinds of errors will also happen. Now, this is your zero error. Sometimes the zero error can be classified as a systematic error also. Why systematic error? Let us say, for example, if I take one object, a scale, another object, a pen, for example, I measure it from here. I measure it from here until this point. Okay. So what does it tell you? It is 1.5 here. This is 12 over here. My length of the pen, as I measure directly here, would be 12 centimeter. But the actual pen's measurement would be 12 minus 1.5, which will be around 10.5 centimeter, right? So every time any object that I take over here, I'll always commit the same mistake if I don't take care of the zero error of it, right? The zero error is very much prominent in scales. It's also prominent in case of the meters, electrical meters. When you start an electrical equipment, first thing what you need to do is, when you connect the batteries to it, look for where is the needle being shown. Okay, before switching on the supply, is the needle exactly showing? Is it exactly showing up the zero, or is it showing somewhere else over here? Okay, that is the first thing that you need to look at. So zero errors will also act out here. For example, without passing an electric current of electric current, if this is now pointing at something like 0.2 ampere, then upon passing the electric current, this may be because of not an electric current present here. It may be because of the faultiness in the spring over here inside it. Okay, then if you pass an electric current of 2 amperes, this could land at somewhere over here at 2.2 amperes. So there's a possibility. So you have to be very careful about it. The next one is about the parallax error. So if you have a vessel and you are finding out what is the value of it, okay, and you don't see it normally in sight, line sight, okay, then you will get an error over here. So what you need to do is, you should always see it perpendicular to it. Okay, the same thing happens here also. That is the reason why you have a mirror behind the dial over here. Okay, this question has been asked, what is the reason for having a mirror behind the dial, okay, in your paper 2? And the reason is that to avoid the parallax error. How do you avoid a parallax error? The needle that you have and the image that you have, these two should be overlapping with each other. If it is like this, you see, the second hand that I am keeping over here is somewhere else, then definitely you will not be able to get it correctly, right? The next one is about the human error. What is a human error? For example, in our earlier days, so what we used to have is, okay, so people used to run from the start to the finishing line. You might be remembering in your earlier classes. Okay, then you would see that when they run, so there will be one person who will be having a whistle, okay, and he will blow his whistle when the runner crosses a finishing line, right? But there are several times, there are several conflicts. People say, I came first, I stepped my foot inside, but he did not take care of it, right? So this can happen. So as a result of it, there's a human error there. It depends upon when is that guy noticing it. Okay, so therefore, so it's not possible to exactly get it using the humans to understand this. So instead of it, you can also put something like a mat, okay, wherein there's an RFID being connected and there's an antenna being connected to a reader. The moment, so there's a tag, this is your RFID. So the tag is now being connected to your feet, and the moment you stamp it on this mat, whoever stamps first, it immediately reads it, and this signal gets transmitted with the speed of electromagnetic radiation, which is 3 into 10 to the power of 8 meters per second. So therefore, if someone has not stamped the mat, okay, he has just kept his leg, he's hovering his leg, and the other one has already stamped into it, definitely the one who has stamped on it will be the winner. Okay, so these are the different types of errors which we have and how to overcome it. We have seen this also. Okay, next is systematic and random errors. Now this slide, I think you would have learned this in your IB1 also. Okay, so now this slide tells you, sorry, yeah, this slide tells you, so you have something like a dartboard, you take an arrow and hit it, right? When you hit it across, what will happen? So the arrows might either land randomly like this. If you are a fresh newbie, then definitely this can happen. But if you are a very targeted person, there's a possibility that you can land here. But there's also a possibility that if you are very good into it, but maybe because of some error, you threw it and almost all the arrows landed over here, which means what? You definitely have a very high precision of throwing it, but there is a systematic error over there. A systematic error. But here, okay, the accuracy is very low and there's also low precision over here. See, this something. So for example, you conduct an experiment in the lab and you get something like this. This is not acceptable. We say, please redo the experiment. There's something wrong in considering your results. Then or maybe getting your readings. But if you do something like this, so what is happening? Let us say you are conducting an experiment on getting the value of the acceleration due to gravity, which is 9.8. Everyone knows it. So you want to get 9.8, but you get the values like 9.8, 10.1, 9.7, 9.3, 9.4, 9.1, and you get values like this, which means what? So you are getting almost higher accuracy, but the precision is not so good. That's what you can say here. Okay, now let us look at this one. So here, the same value of 9.8. Okay, let us give an example here also. Here, instead of 9.8, you are getting this as 9.8. This is 9.8. This you are getting it as something like 8.7, 7.3, 7.3, 4.7, 5.1. Then you have something like 6.3 and so on. You get different values like this. Definitely, this is not acceptable. This one you are getting it, but still your precision is not very good. Okay, accuracy is good enough. Now let us look at this. So the precision is very, very high. Okay, what is the value? Let us say you are getting 6.6, 6.7, 6.5, 6.65, 6.8, 6.71, 6.73. You're getting some values like this. But almost you see this is being centered around 1 point over here. So therefore, this is also always a okay one. But still, okay, there is some error which is being seen there, which affects your accuracy. So you need to look into that also. The last one is this, which everyone desires, okay, an ideal one. So wherein you are supposed to get 9.8, you get 9.8, 9.81, 9.82, 9.8, 9.81, 9.79, 9.81, 9.8. Now you see, it's almost centered around it. So this is always acceptable. Okay, you are an ideal student if you get a result like this. But many times you will not get this one. You might get something like this also here. Maybe some points are scattered over here. This is also possible. So this is completely not acceptable. This has to be verified. Okay, why did you get something like this? There is a systematic error. There's a systematic error over here. And here, this highly ideal. This is completely ideal. It's completely ideal. And this one is most of the time we get these kinds of results. Okay, let us move on to the next one. The uncertainty in reading an instrument is plus or minus half of the smallest, let me move my photo here, smallest width of the graduations on the instrument. For example, in a ruler, now we are learning about uncertainties. So what is an uncertainty? Uncertainty is a reading an instrument is plus or minus half of its smallest width. In a ruler, what do you see in a ruler? A ruler looks like this. Why is my pen not being seen clearly? Let me put it into white color. Right. A ruler looks like this. This is your ruler. And this is your zero of the ruler. Then you have 1 centimeter here. This is your 1 centimeter here. In between them, there are 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You have this. So what is the distance between one division and the other division? Which is 1 millimeter, 1 millimeter, right? The smallest division on the instrument is 1 millimeter. Now what you do is you take this 1 millimeter, divide this by 2, which you get this as 0.5 millimeter. This would be your uncertainty which you have. Sometimes this uncertainty is also called as the, this is your uncertainty. Okay, in a vernier calipers 0.05 micrometers, it is so much. Electronic weighing scale 0.1 grams, stopwatch is 0.01 seconds. So this is called as an uncertainty. Okay, next. Now we have handling uncertainties in calculations. Okay. Now, just a moment. Let me see. So we have so far learned about what is an uncertainty in an instrument. Okay, so we will stop here and continue with the next video about how to calculate uncertainties in equations and then proceed on thereof. Thank you.